Okay, so for today, we're going to implement the add vertex and add edge using the adjacency list. We're just going to use a slice for the list instead of the linked list, just for simplicity, and it's also a basic data structure that Go provides, so for efficiency, we're going to use slices. Okay, first we will implement the structure of the graph and vertex. First, we're going to implement the structure of the graph and vertex. So, and then we're going to implement the add node and add edge operations. So, and we will need some other methods and functions that's going to be used when we're implementing add vertex and add edge. Things like a simple function that can get a vertex. Okay, so now let's go and write the graph structure. We didn't write the vertex struct yet. That's going to be our next step, but the graph structure would need a list that holds vertices and the pointers of vertices in a slice. And for the vertex struct, which is going to be here, and it should be holding a key, which is going to be just an integer. And because we're implementing an adjacency list, each vertex in the graph will have a list of vertices that are holding the vertices of the neighbors. So that we'll call it adjacent, and that would also just look like a slice of pointers to vertices. Okay, so next on the list is to write the add vertex method. We will write it as a method to the graph with a pointer receiver. And it's going to take in an integer, which is a key to add. And inside the body, we first create a vertex that has k as the key. So this. And then we're going to append this to the vertices list in the graph. g.vertices, which is the vertices list. And okay, so let's go and do a little test. So we need a main function to do that. And I'm going to create a very simple graph. Let's just call it test. And let's just go and add some nodes to it. I'm just going to use a for loop. And I'm going to add the keys from 0 to 4. Okay, that should do it. And now let's just print it out. Print ln. And just print the whole thing. You can see that we have a list of addresses. If you want to see the actual keys, the values to the keys, then you'll have to print out the vertices of test, indicating which index you want to print out. We can do that by writing another function that can print out the contents of the graph. So let's go quickly just add that. I didn't mention that before, but let's do that. And there are no parameters. And inside the body, we're going to use a for loop that can loop over the vertices. So and we're going to loop over the vertices. And inside here, we will print out the key for each vertex. And let's make another loop that can actually print out all the vertices inside the adjacency list. Okay, instead of this, we will try to do test dot, and let's see what it gives us. Okay, nice. Right now we don't have any edges, so all the adjacency lists are going to be empty. Let's just put a line break here. Yeah. Okay, that looks better. And just gonna put some space here. So we have some space between the keys. Okay, so far so good. But right now we are able to add duplicate keys. For example, if we try to do this, so we already have 0, but I'm going to add 0. Yeah, we can just keep on doing that. And if we run that, you can see that we can have duplicate key values. But if we want to have the keys unique, then we'll have to write a part where it can prevent this. So let's go and add a little bit to the add vertex method. So before we add the new vertex to the list, let's check if the key is already in the vertices of the graph. So this is where we need to write this. We can just write it straight here, but it's also a function that we might use in the future again. So I'm just going to write a new function called contain. And then we're going to take in a vertex list and a key. And it's going to return true if that list has that vertex with that key value. We'll just go S, just call the list S. And inside that function, we'll just loop through the list and return true if there is a match. Very simple. So if K is same as the key, then we'll return true. And if there is not a match or any other cases, we're just going to return false. And then let's go back to the add vertex method, and we're going to put in a statement to check whether the vertices in the graph has that vertex with that key. So before we actually add it, we'll have to check. So if contains. And so if this statement is true, it means that it already has that key. So we'll just print out an error message. Just go. Okay, that's how you can print out an error message. And if it doesn't have that key, we'll write that part in the else statement. And this is actually where we need to put in the part where it adds the key, which is the one that we just wrote. So if we just try to do the same thing, like in the main function over here, we try to add this. The zeros are not added, and we don't have that here. Okay, you can also like call a panic, but I don't want to just stop the whole thing just because it has, we try to add an existing key. So that's why I just put it as a very simple error message. Okay, so next on the list, we have to write the add edge method. And this is going to be a little bit more complicated than the add vertex, but I'll try to explain it as simple as possible. Okay, so we're going to take in two integers for the keys. The first one is going to be the from key, so we'll just call it from. And the second one is going to be called to. Okay, and they're both going to be integer values. We're going to implement a directed graph, so there's going to be a from and a to. For example, add edge 1 to 2 would mean something different from add 2 to 1. If this was an undirected graph, if we put add edge 1 to 2, then we'll have to implement adding 1 to 2 and 2 to 1. But because this is just a directed graph, we're just going to implement just one side. Okay, so we're going to be doing three things. First, because we, as parameters, we only got an integer, we need to find the vertex that has that key. So first we'll get the address of the vertices, get vertex, and then we will add the edge. And before we do that, we will also check the errors. So for example, if the edge already exists, or if we're trying to add an edge to a vertex that doesn't exist, we need to kind of filter out that, just like we did with the add vertex when we were checking duplicate keys. Okay, first getting the address of the vertex based on the keys. So we're going to make two new variables that hold the address of the from and to vertices. So from vertex is going to be g.getVertex from, which is the parameter, and to vertex should be g.getVertex to. So getVertex is returning a pointer to a vertex, like an address, and then that would be stored in from vertex and to vertex. So now we got the addresses of the vertices. And next, we'll leave this for later. Let's go and just write a line that can add an edge to the adjacency list. First, we need to go to the from vertex. So from vertex. And we're going to go to the adjacent list of the from vertex. And then we'll just append. Okay, so right now I just went to the adjacency list of the from vertex and added a pointer of the to vertex. So just with this, we can start just adding edges to our graph. So let's just pretend there are not going to be any errors, and let's just see if this works. So go to the main function and let's just get rid of this. Yep, get rid of that. So right now we don't have anything here. I'm going to add edge. Let's add an edge from 1 to 2. From vertex 1, we have a neighbor, vertex 2. So 1 is pointing to 2 right now. But like I briefly mentioned before, right now we can just add 2 vertices that don't exist, which will give an error. And also we can add this again, which doesn't make much sense. So let's go and handle these kind of situations. So go back to the add edge over here. So first we're going to check if the vertices actually exist. So if the getVertex method returns a nil, we're going to give an error. If either of the from vertex or to vertex is nil, which means that there is no match in the getVertex method, return nil, then we'll give an error message saying that it's invalid because we're trying to add edges to vertices that don't exist. Okay, so we only want this to run if this doesn't. So if this runs, we just don't want to add it. So that's why we need to put that in the else statement like that. In the main function, let's say we want to add an edge from 6 to 2. We only have vertices from 0 to 4. So this is going to give an error message. Let's see if that works. Okay, so we have an invalid edge, 6 to 2. It's still going to run, like whatever we put under here. Let's say we add another edge, 3 to 2. Even if we have this error, this line is still going to run because we're not stopping the whole thing. We're just giving an error saying that it's not added. Yeah, this is added. Okay, and another thing we need to check is right now we can add duplicate edges, which we don't want. So let's go and handle that as well. Right after the if statement, right before the else, we are going to put an else if. So if it contains, so right now what I'm doing is if 2 already exists in this list, the from vertex.adjacency list, then we are going to give an error saying okay, so it's going to also check whether it already exists. And what's going on here? Oh, right. So I'm going to run it and let's see. Right now in the main function, we have this is adding an edge that already exists. So it's giving existing edge. And this doesn't exist. This vertex doesn't exist, so it's giving an invalid edge. But it is still running all the valid add edges. Okay, so that's it for today. I thank you so much for watching until the end. If you like this video, please like and subscribe, and I'll see you in the next video. Okay, thank you.